Hey, what's up? My name's Hank, aka Cali Green. So this channel is one of the original content creators for cannabis cultivation. I started back in 2012 when there really wasn't many guys doing this. Yeah man, I practically invented the seed to harvest style. I just want to say thank you for those who've been following me, know who I am, and if you don't know, you have just tuned in to a Cali Green grow video. If you're a first time grower, have never grown before, or just like watching grow videos, click subscribe, hit the notify bell, and grow along with me. There isn't just one definition of soil. Soil is usually made up of many different elements. The natural soil in my backyard is going to be different than soil you find in another state or another country. The soil in my backyard may be totally different than my neighbor's. Every soil has a base, or what's called the parent material. This parent material is probably formed over thousands of years by sediment laid down by wind, water, and ice. The parent material is not exactly soil, but it's important because it dictates the type of water drainage, slow or fast. Sandy parent material leaches out minerals quickly. You find these types near riverbeds and beaches, but there's other places like the Mojave Desert, which was covered by a shallow sea at one point. Clay parent material is most likely formed deep underwater in prehistoric oceans and lakes. Clay does not drain very well at all, but it has a crazy CEC and it's able to retain nutrients really well. Only problem is plants can't really access it. The type of parent material is going to vary widely throughout the world. You may be in an area where there's lots of dolomite, lime, or maybe granite and quartz. The type of elements in your parent material affects the pH in the long run. In most cases, you're not going to have a specific type of parent material. It's usually made up of a combination of all of these. Climate played a major role in the development of the soil in your area. Minerals and organic matter break down a lot quicker in hot areas. Rainy environments wash out minerals and nutrients and carry them away deep into the earth. Dry environments causes evaporation from the soil and the plant leaves. This creates a collection of minerals near the surface of the soil. Desert environments are just poorly developed, and we'll talk about that a little bit later. The type of vegetation that has existed in your area is one of the most important parts when it comes to organic gardening. This is because the organic matter that falls onto the ground and decomposes makes up a major part of the soil in your area. Not to mention the microbes and arthropods and other animals that have died and decomposed and returned their nutrients back to the soil. Areas with little vegetation and little organic matter in the soil, like deserts, are not very fertile. So the combination of parent material, environment, vegetation, and time has made up the composition in your soil. This may not seem very important to you when you're growing indoors in store-bought grow medium like Fox Farm, but the understanding of this is what's made my grow successful. So let's break it down and convert it to organic indoor grow medium. The parent material dictates the water retention. It also affects the pH in the long run, but we'll worry about this later. The options I have commercially available to me are cocoa and peat moss. Peat moss is very acidic. It has a very low pH, 4.5 to 5, but it retains nutrients and water very well. Peat moss is harvested from marshland. The only downside is that it's not a renewable source. Once it's gone, it's gone. My second option is cocoa coir. I can't even pronounce it, but I know it's made from coconut husk. Cocoa retains water just as good as peat. It does pretty good with nutrients as well. But I've heard that it likes to hold on to calcium and potassium more than peat moss. It won't release it to your plants, it's greedy. Both of these work great, and I can't really recommend one over the other. So now we have a base material that retains water really well. But we also need drainage, because if we don't have drainage, then our roots will starve for oxygen. Oxygen is important to the plant roots and also to the microbes. There's many choices when it comes to this. You can use gravel if you want, but then your mix would be too heavy. Anything that creates space in the yeah, space in the base. Space in the base grow medium. Space in the base. Space in the base. Space in the base. Space in the base. Sorry about that, I got a little carried away. I like to use perlite because it doesn't weigh a thing. Perlite is a mined mineral made from volcanic glass. So please try not to inhale the dust when you're mixing this in. The perlite's going to give us the drainage and aeration we need. Okay, so now we have a base medium that holds on to nutrients and water. And we have drainage. So now we need a substitute for the decomposing vegetation. There's different types of compost. Some of them are made from animal waste and decomposed vegetation. Others are just decomposed vegetation. The compost is going to be rich in micro and macronutrients decomposed from the vegetation. It's also going to be rich in microbes. Worm castings are worm poop. Worms digest organic matter. Their poop contains micro and macronutrients and also microbes. It's also important to know that these materials themselves have a density to them and they retain water. They also have the ability to retain nutrients just like your base material. As a rule of thumb, all decomposing organic matter is neutral. Nurseries, hardware stores, and grow shops usually sell organic fertilizers. These organic fertilizers are usually made up of organic matter that hasn't decomposed yet. People call these slow release, but that's just a marketing scheme. A better word would be decomposing fertilizers. It doesn't sound as attractive. The organic matter found in these fertilizers can be plant or animal based. It could be fish bone, blood meal, alfalfa meal, guano, kelp meal. This is usually what I look for. Okay, so we have a base material, cocoa. It retains water. It holds nutrients. Then we have drainage, perlite. It allows oxygen to the roots. It allows water to drain through. Then we have organic matter, compost, worm castings, and an organic fertilizer. It's that simple. I get asked about pH pretty often. Now the following information is just personal ideas. Look, I'm not a scientist. I'm not even that smart. I'm just a guy that grows weed in his house. But like I always say, don't take this as law. This is in the Bible. Only way we can advance is through experimentation and trial and error. I read about nitrogen fixating bacteria, and it could have been in teeming with microbes or somewhere else. I don't remember. But what I read was that they prefer neutral environments. Because of this, I try to create soil mixes that are close to neutral. The base material is a major factor here, but so is the compost and the worm castings. A lot of guys are going to tell you that plants cannot absorb the nutrients they need in a neutral environment. And they're right, but they're also not growing organically, or just don't understand how organics works. You see, plant roots excrete exudates. These exudates are usually sugars or carbs. They do this to attract certain types of microbes to the area. Now the microbes also have excretions, and these excretions are also acidic. They're used to break down organic material. Your plant takes up minerals from the soil, but for every mineral it takes, it has to leave one behind, and it's usually hydrogen. The cation exchange, the biofilms, the exudates, all these contribute to the soil pH. They're balancing each other out. This is the reason why I don't pH. pH is an abbreviation for potential hydrogen, and this is the measurement of acidity on a scale from 0 to 14, 0 being acid, 14 being basic, and 7 being neutral. The more hydrogen ions you have in your solution, the higher the pH. And I want you to keep this in mind. We'll come back to this in a bit. Microbes are one of the most important parts of growing organically. Bacteria lives and moves around in water. They reproduce by simple cell division. If the conditions are right, they will reproduce. These guys actively seek out organic matter, mostly carbs and sugars, but different microbes eat different things. And once they find it, they use enzymes to break it down. Enzymes are mostly acidic. They absorb the mineral nutrients and hold it in their body until they die or something kills it. There are predators, but that's another story. A lot of people don't know that materials in your soil are either negatively or positively charged. Mineral nutrients also have a charge. Soil materials are able to attract and hold mineral nutrients. Some bonds are stronger than others. Positively charged ions are called cations. Negatively charged ions are called anions. These mineral nutrients will stay in place until the roots reach them and absorb them. But the roots just don't take up these nutrients, they actually exchange them for hydrogen. This is called the cation exchange, and it happens every time that your plant absorbs a nutrient. But wait, there's more. Your plant not only releases hydrogen ions, it also excretes exudates. These exudates are mostly carbs or simple sugars, and they're meant to attract bacteria. Fungi propagates through spores. They create fibrous web-like structures that interconnect with each other. Fungi also uses enzymes to break down organic matter, but their enzymes are a lot stronger and they're able to break down tougher materials. They're able to absorb mineral nutrients and water and transport them anywhere along their structure. The enzymes continue to break down organic matter even after the fungi is long gone. Let's put all this together. The enzymes are acidic. Exudates and cation exchange increase pH. Organic materials break down and decompose and affect the pH in their own way. So the point is that in organics, everything works against and with each other to create balance. This soil mix is 100% organic. The basic idea is to grow and maintain good bacteria in your soil. You take care of the bacteria, bacteria will take care of your plants. My base soil is Fox Farm Ocean Forest. I use this because it's available locally, but they also use really good organic amendments. The texture is light and airy, and you want this because your plant roots love oxygen, and the good bacteria love it too. My second ingredient is compost. Now this is not the best you can get, but it was all that was available, and sometimes you just gotta make do with what you got. 3 simple ingredients in here: composted wood, mushroom compost, and sand. And the idea is to provide different sources of organic material for your bacteria. I also amend my mix with organic fertilizers. I've been using Dr. Earth's Flower Girl mostly because it's OMRI certified. It's got all kinds of good ingredients like fishbone meal, feather meal, alfalfa meal, kelp meal, seaweed extract, rock phosphate. It also has all sorts of different strains of mycorrhiza. And last but not least is my secret weapon, worm casting. It's got all sorts of minerals, microbes, and bacteria. It holds water really good too. Alright, so let's get this soil mixed up. As I mentioned earlier, I start off with a Fox Farm base. I add 8 quarts of compost, 5 quarts of worm castings, 1 1/4 cup of Flower Girl, and 5 quarts of small perlite. Mix it up really good so all the ingredients are spread throughout the soil mix, and you're done. The soil mix is ready to use. 71% of Earth is water. Human bodies are about 60%. Plants are about 90%. Some microbes are up to 99% water. Microbes depend on water just not to move around, but also just to exist. They're kind of like fish swimming in the water in the soil, and a lot of them are really sensitive to water quality. 2 parts hydrogen, 1 part oxygen, right? Well, not really. The water that you drink is much more than that, depending where it comes from. Let's take, for example, water in the LA County. Well, we don't really have water. Not that much anyway. Most of our water comes from other places like Colorado, and some as far as 400 miles away in Northern California. It's brought down in man-made rivers called aqueducts. You can almost imagine all the stuff it picks up along the way. And this is great because it's probably loaded with fish and all sorts of microbial life. Now this water is brought down to water treatment plants. It's screened and then put into settlement tanks. They allow the silt and the bigger particles to settle to the floor, and then they pump it out to other filtration processes. Depending on where you live, it usually involves mechanical filtration and some kind of chemical disinfection. The disinfection process is usually done right at the end, when the water is sent out to you as potable drinking water. Disinfectants are used to kill bacteria and viruses. It also ensures that bacteria doesn't get picked up on the way to your home. This is done to keep us safe. Water treatment plant workers are heroes and we don't even know it. The problem with disinfectants is that they kill microbes, and we need microbes to convert organic matter into plant-usable nutrients. Sodium hypochlorite is pretty much chlorine, and this was a standard disinfectant in cities for a long time. The problem with chlorine is that it evaporates real quick, and that's all bad if the goal is to kill microbes before people drink them. Chlorine is easy to remove. All you have to do is air it out. Some people use an air pump and stone and bubble it out overnight. A simple carbon filter also gets the job done. I just want to take a quick moment to thank Mars Hydro for sponsoring this episode. If you're looking for a grow light or a tent or the complete setup, Mars Hydro's got them. Please make sure to use my coupon code to get a discount. Chloramine has replaced sodium hypochlorite in most cities. This chemical can't be bubbled out. It stays in the water much longer. Chloramine has to be filtered out, but a simple carbon filter won't cut it. But we'll talk about that later. Water filtration can be mechanical, chemical, or a combination. Let's take a look at the ones that I know about. A sediment filter traps and removes visible dirt and debris from your water. Think about a coffee filter. Actually, it's almost exactly the same. Manufacturers use all sorts of materials to do this. I've seen cotton, paper, plastic, metal, and they're available in different micron pore sizes too. This is important because the bigger the micron, the bigger the particles will pass through. These type of filters are considered mechanical, and they don't remove any chemicals at all. They're mostly used to remove debris so it doesn't mess up the other filters. Activated carbon filtration is a chemical filtration process. Activated carbon is very absorbent. It will absorb organic molecules suspended in water into its pores and hold it. Carbon is good at removing chlorine, small sediment, some organic compounds, and odors. Reverse osmosis membranes are like sediment filters, times like 1,000. The filtration material is usually made of some kind of plastic material. The ones I've seen anyway. The pore size in the RO water system membrane is so small, it only allows water molecules to pass through. It's capable of actually removing about 90% of impurities from the water. Now, even though this water is super clean, it still holds an electrical charge. Deionizers remove this electrical charge. Ions are electrically charged atoms or molecules found in water that either have a negative or positive charge. DI filters are filled with chemically charged resins. The charged resins steal the water's charge. The problem with DI water is that it's super hungry. It'll steal ions from whatever it comes in contact with. This is called aggressive water, and it's very corrosive. You can't even drink this water. It'll probably kill you or make you real sick. There's aquarium enthusiasts that use DI water and then recharge it with salts. Water softeners remove calcium, magnesium, and other minerals from the water. Water softeners work in a similar way to deionizers. They use resins preloaded with sodium or potassium to create the exchange. So this means that the water is now free of calcium and magnesium, but it's replaced with sodium and potassium. There's a few cities out there that use a combination of bacteria and UV to remove organic compounds and also the bad bacteria. There's places around the world that have great drinking water, and filtration is something you don't have to worry about. Some people have access to lakes, ponds, rivers. I truly envy all of you because all the rest of us have to use some kind of filtration. So how do you choose a filtration system for your needs? Well, first of all, you gotta identify what's in the water, and that's pretty easy to do. All you have to do is Google your city's name and the words water quality report behind that. This is public information and should be accessible. Now, if your city uses only chlorine or a microbial UV method, congratulations, you don't need a filter. If they use a combination of chemicals, or if they use fluoride or chloramine, then you're probably going to need an RO filter. But Callie, my plants grow just fine with tap water, and my city uses chloramine. Yes, they do, because microbial life is resilient and abundant. But I believe that my job as a grower is to provide a close to perfect environment as I can for the microbes in the plant. Humans can also survive in extreme locations, but we avoid them, right? Look, at the end of the day, if you're just starting off in this hobby, you can definitely go without a filtration system. But as you get more serious into this hobby, and especially into living organics, then you're probably going to want one. But like I always say, ain't no rules to this. RO systems are rated by the amount of water they can create in a single day. A 100 GPD unit will produce 100 gallons of water in one day. That's 100 gallons every 24 hours. But this is only going to happen if the temperature is 78 degrees and the pressure is anywhere from 40 to 60, or whatever the range is for the unit that you have. If the water's colder or the pressure is not sufficient, then it's going to take a lot longer than that. So when choosing an RO system, the question you should ask yourself is, how quickly do I need that water? Now, RO filters also create wastewater. For every gallon of clean water the system makes, it wastes 4. This is called a 4-to-1 ratio, and it's pretty standard. But there are some companies out there that make a 2-to-1 or a 1-to-1 ratio. The rejected water that these systems produce can't be used. It has to be disposed of. Okay, so we talked about water quality, but the number one question that I get asked is, how do I know if I water too much or not enough? And this is a hard question for me to answer, because this kind of stuff is just something that you just know. So what I can do is give you some pointers to help you along until you get to that point when you just know. The amount of water that you're able to absorb and hold really depends on a lot of things. The soil material, the humidity, the temperature, the pot size, and sometimes even the strain. Most materials absorb water pretty slow too. So if you water too quickly, it's just going to repel it. Instead of me trying to explain how to do it, let me explain how I see it. So water makes up more than 80% of the weight in your soil mix. Some materials in your mix are porous and hold the water in their pores. Peat and cocoa are able to absorb it and hold it. And there's materials that create spaces to allow oxygen into your soil. It also creates drainage. Water is also charged, so it kind of sticks to itself. Water always follows the path of least resistance, and since it's magnetic and stuck together, it all flows down the same path, unless disrupted. So since we know that most soil materials absorb water slowly, and we know that it sticks together, then we know that if we water too quickly, the material is not going to have enough time to absorb the water, and the water is going to find a path of least resistance and run out the bottom of the pot. This is the reason why I water so slow. Watering my 15-gallon pot might take 30 to 45 minutes. So if I'm watering in 1.5 gallons, I might spray in about 1 quart with my pump sprayer, let it rest for like 10 minutes, come back, do it again, let it rest for 10 minutes, come back, do it again, until I'm done. You know, I'm not in a rush, I'm a hobby grower. I don't got a schedule. This ain't going to market, so I could afford to take my time and do it right. The amount of time that it takes to fully saturate the materials in your soil is one thing to think about, but how long it stays in there is another. Sure, the material itself plays a role how long it can hold that moisture, but temperature and humidity really make the biggest difference. If the room is hot and dry, the water is going to evaporate quicker. If it's humid, it'll take longer. But temperature and humidity also affects the plant. This is because plants exhaust water vapor through their leaves, and it all has to do with the temperature and humidity. You see, temperature affects the rate at which water moves through the plant out of the leaves. This is called transpiration. The hotter it is, the more transpiration, the more water sucked out of the soil. Humidity also plays a role because the more humid it is, the less the plant transpires. And you can find vapor pressure deficit charts anywhere on the internet. And they're pretty cool. I like them. So the amount of time before you have to water again really depends on the soil material, the temperature, the humidity, and sometimes the plant itself. But the plant also talks to you, and if you spend enough time with her, you'll start understanding. The way she carries her leaves is a language. Are they droopy? Is she usually carrying them more perky, more confidently? But I don't ever let the plant dry out and get droopy. There's very slight changes that I can notice. It's in the firmness of the leaves and stems. But like I mentioned, it's very slight. If it wasn't in a plant that I was growing, I could probably mistake it for something else, like maybe too much water in the soil, or the plant's getting root bound, or there's root rot, because only you truly know what the temperature and humidity has been in your room and the percentage and materials that your soil's made of. But this is very difficult for a new grower. And there's a few tricks you can use to help you along until you're just able to tell. A water meter is a sure thing. Just make sure you're careful when you're poking around. Another thing you could do is fully saturate your soil. Pick it up and take a mental note. The weight that you feel is fully saturated. If it feels half as heavy as that, then you know you have to water. So now you know everything I know about water and how to water. But don't take my word for it. Try it for yourself. Your plant can only express its full genetic potential if the minimum nutrient requirements are met. I amend my soil with an organic fertilizer mix right at the jump. All I have to do after that is water and keep the microbes alive. Bacteria covers every inch of this earth. They're diverse and abundant. We don't even know how many different kinds there are. We're almost always finding these strange microbes living in extreme places. Microbes are the reason that anything decomposes. Without microbes, the earth would pile up with organic matter. Nothing would decompose. But that's not all they're good for. As microbes decompose organic matter, they convert it to plant-usable nutrients. This is really important because plants cannot absorb organic matter. They can only absorb minerals. When growing organically, the goal is to replicate nature as close as possible. So how does nature feed the plants? I know for a fact that nature doesn't go down to the hydro store and buy bottled nutrients. Nah, that's not what she does. Nature recycles everything. The reason that I use aerated compost tea is to restore and increase the microbial life in the soil. Aerated compost tea not only adds microbes to the soil, but it also feeds the existing microbes. When growing organically, if the soil microbial life is happy and feeding, then your plant is also happy and feeding. This is because microbes decompose organic matter and convert it to plant usable nutrients. So let's talk about compost. Compost is organic matter that has been decomposed. And guess who decomposed it? Yup, microbes. Compost is rich in the nutrients of the material it's made from. It's also filled with fungi, earthworms, and small arthropods. But best of all, it's loaded with bacteria. Now, earthworm castings are the result of digestion of organic matter by worms. This is pretty much worm poop. Because the organic material has already been digested, it contains trace amounts of available nutrients. And it's also loaded with worm gut microbes, and they're great decomposers. Both compost and worm castings are an excellent source of microbes for your tea. And the goal is to increase the amount of microbial life already existing in these two materials. And that's pretty easy, because microbes will duplicate themselves pretty quickly as long as there's moisture and food. But before I explain how that works, I want to give a quick shout out to Vermiterra for sponsoring this episode. Vermiterra makes some of the best quality earthworm castings on the market. They also brew up their own worm castings tea, and this will save you a little time. Please check out their website when you get a chance, and don't forget to use my coupon code to get 10% off on any of their products. Simple sugar serves as an excellent bacterial food source. You can use molasses, honey, maple syrup, cane sugar. I prefer to use molasses because it dissolves pretty easily. A lot of my subscribers live outside the United States and they don't have access to molasses. But you know what though? Any type of simple sugar will work. One of my subscribers started juicing apples and he said it worked pretty good. Now, seaweed extract and kelp meal are not only loaded with trace minerals and growth hormones, they also encourage the growth of microbes when you use it in compost teas. And certain types of microbes are also able to absorb amino acids as a food source. So let me show you how I make my compost teas. As always, I've left a list of materials and Amazon links in the description section of this video. So all you need is moisture, a source of microbes, oxygen, and a microbial food source. Let's start with a microbial source. I use compost, worm castings, or a mix of the two. Now, both compost and worm castings can be made at home. It does take a little time and dedication, but the upside is it's free. I usually use 1 or 2 cups of each per gallon of water. Another source of microbes can be captured from your own backyard. This is, of course, the easiest free option. All you have to do is find an area in your backyard where the soil is fertile and alive. Collect the soil and use it in place of compost and worm castings. What's great about indigenous microbes is that they're acclimated to your region, so the environment won't kill them. Okay, so now we have a source of microbes. RO water in a bucket provides the moisture. A simple air stone and pump provides the oxygen. All we have to do now is find a food source. I use molasses and seaweed extract as a food source. I typically use 1 tablespoon per gallon of water. Temperature affects the rate at which these microbes duplicate. The cooler it is, the less active they are. But if the temperatures are between 75 and 80, the tea should be ready to use a lot quicker. My tea usually brews 12 to 24 hours. Foam forming at the top of the brew is a sign that the proteins, amino acids, and carbohydrates have broken free, which also probably means that the microbes that once lived in the compost and castings have also broken free. I imagine them floating around in the water, eating, duplicating, and just having a great time. The foam doesn't really have anything to do with quality though. It's really just caused by agitation from the bubbles. Aquarium enthusiasts know this as a protein skimmer. The same exact process is happening when you bubble your tea. I usually water this type of tea at full strength. This is a very basic tea, and I can use this in any stage of the plant's life. If I really wanted to, I can use it every watering, but I mostly just use it once a week. The main purpose of this type of tea is to increase and maintain the microbial activity in the soil. That's it. You can also make feeding teas. These type of teas are made from ingredients that have higher nutrient values, guanos, fish emulsion, and things like that. These type of teas are made by soaking the amendments, the microbial source, and the food source in aerated water and then collecting what leaches out. The leachates contain minerals and microbes which are then watered into the soil. If you're part of my Patreon, then you receive the recipe card with a few of my compost tea recipes. Patreon is a way that you can support the channel and get a little something in return. But you know what though, all this information is free, and all you really have to do is go back and check out my past videos for those recipes. Now the purpose of these type of teas is to get the minerals down into the root zone. There's also anaerobic teas. In these type of teas, the organic matter is allowed to ferment without air. I don't know enough to talk about them in depth, and I really just started experimenting with them. A good source of information for this type of tea is JDM Natural Farming. The book is written by Young Sang Cho. I left the Amazon link in the description section of the video if you want to check that out. Now there's some really smart people out there, some of them professors in universities, and they argue that compost tea has less value than top-dressed compost. They have references to published data, and they're also experts in their fields. The argument seems to be that the concentration of microbes are higher in the compost than they are in teas. They also argue that the cost of teas is way higher when used commercially. The counter argument is that full-strength teas show good microbial activity. They also deliver microbes deep down into the soil, and top dressing with compost only really sits on top. They argue that the benefits of compost takes longer, while compost tea is delivered deeper and shows benefits much quicker. I personally use both methods, top dress and compost tea. I feel like top dressing creates a top layer that slowly changes the structure of the soil, which is great. I also feel that plants seem to react faster with compost tea. I think that I can get the best of both worlds and don't have to choose one over the other. Look, this is my opinion and you don't have to take my word for it. Do your own research, experiment, try things out, come up with your own ideas. Like I always say, there ain't no rules to this. If you want to learn more about the no compost tea side of the argument, look up Linda Chalker. She's a professor of horticulture at Washington State University. To find out more about compost teas, look up Jeff Lowenfels, and more specifically the book Teaming with Microbes. I left an Amazon link in the description section of this video. Elaine Ingham is a microbiologist and a great source for information on compost teas. I know this seems like a lot of work, and some of you guys don't have the space, time, or equipment needed like Bucket, Air Pump, and Airstone. There's plenty of companies that make ready-to-use microbial inoculants on the market though. There are even companies that make tea bags that are ready to be brewed. And you could always go the top-dress compost route if you really wanted to. What I'm about to show you is my personal technique. I've never heard anyone use this or even mention it before. And I've never talked about it because there's other YouTubers out there that like to take my techniques and not give me credit. This is not FPJ. Again, this is not fermented plant juice. You can let this ferment if you want, but that's not what this is about. This is the Cali green juice. So the recipe is real easy and you don't need much to put it together. All you really need is water, kale, molasses. I'm not using the correct juicer either. There's juicers made specifically for leafy greens and herbs, but this is all I have, so this is what I'm going to use. Now all we have to do is juice this kale. The kale I'm using today was in the fridge for a few weeks and it's starting to turn yellow. I'm not going to be able to eat this, but my plants are going to love it. Now you don't have to use kale, and it doesn't have to be going bad like mine is. As a matter of fact, you can use it fresh. I've actually done it with spinach as well, and that worked out pretty good. Now because I don't have the right type of juicer, I'm not going to be able to extract as much. So what I like to do is run the material 3 to 4 times to extract the most juice possible. And this stuff is also gold. You can compost this. I was able to pull half a cup out of 3/4 of a bag of kale. And this is perfect. This is exactly what I like to use. I'm going to pour this juice into a 1-gallon jug. I then add half a cup of warm water to my measuring cup. I add 1 tablespoon of molasses to the warm water. The warm water is going to help dissolve that molasses. I pour the molasses into the jug. After that, I just fill the jug with reverse osmosis filtered water. I don't fill it to the top though. I want there to be space for air. I give the bottle a shake and it's ready to be stored. I keep this bottle in a cool, dark place, no more than 75 degrees. And I shake it at least 2 to 3 times a day. It's also important that you open it about 3 times a day when you shake the bottle to allow air into the mix. This green juice can go into your soil immediately, and your plant reacts to it just as fast. Now this is a big amount of organic matter all at one time, so I don't do it that often. So this is how I think it works. Fresh green leafy vegetables such as lettuce and spinach contain high amounts of nitrates. Spinach also contains a good amount of potassium, calcium, and iron. Molasses also contains trace amounts of potassium, iron, and calcium. And don't forget the sugars. Juicing makes it easier for the microbes in your soil to break down and absorb the spinach in its organic form. I feel like the microbes are able to convert the spinach juice into plant-usable nutrients a lot quicker. I picture millions of microbes rushing to the area where the juice was poured, creating a feeding frenzy. I also feel like the juice alone is capable of promoting the reproduction of microbes in the same way the compost seed does. These are all just ideas though. What's really exciting about this is that there's endless possibilities, and we as a community can actually turn this into something way bigger. I've had a Patreon member experiment with fresh squeezed apple juice instead of molasses for sugars. Makes perfect sense. That's what I'm talking about. We can turn this into something great. So far I've only used leafy vegetables, but the possibilities are endless. Environment directly affects the growth and development of your plant. The purpose of your grow space is to maintain a controlled environment. Choosing an adequate grow space is not that difficult as long as you know the requirements. You basically just need a room where you can control the light and environment. I like using grow tents because they're easy to set up and they have all the ports I need for intake and exhausting air. They also have a reflective interior. Air movement is important inside of your grow space. The air movement disperses stagnant air that can cause excessive odor. It also makes your stems thicker and stronger. The air movement can also cool down leaf surfaces. I use small clip-on fans at canopy level and a small floor fan to circulate the air below the canopy. Intake and exhaust is equally important. You need to be able to remove all of the air inside of your tent within a minute and replace it with fresh air. Exhausting your air can help reduce heat buildup and also increase or decrease your humidity. I install my exhaust ducting high in the tent to remove all the hot air that rises from my grow light and other equipment. Exhausting your space also reduces the smell and carries it away from your grow room. Mine exhaust out the window. I can't have my neighbors getting nosy, so I've added a carbon filter to remove the smell. Carbon filters work really well, but you can't be cheap. I've used the cheap eBay filters, and they don't work that great. I'm currently using the Black Ops carbon filter. Intake can introduce fresh CO2 and cool air into your grow space. There's many ways of doing this. I'm going to show you my two favorite. 1. You could push cool air into your tent with a duct fan. 2. Your exhaust fan creates suction in your tent and pulls fresh air in. For this to work, your tent needs to have ports that allow the air to flow in. These ports cannot allow light to seep into your grow space. I usually go with the exhaust setup. This works really good for me because I live in LA and only grow in the winter when the temperatures are cool. If my daytime temperatures get too cold, all I have to do is decrease the fan speed. If my nighttime temperatures get too cold, that's a little bit more difficult to deal with. That's because the grow light is my main source of heat in the grow space. In a situation like this, you'd have to find a source of heat. Some people like to use space heaters, but I usually just turn on my dehumidifier to warm up the grow space a bit. If I decided to grow in the summertime, when the temperatures are hot, I would have to use a portable air conditioner unit to maintain a comfortable environment for my plants. It would also require a controller like the autopilot to monitor temperatures and operate the AC unit. This controller can also operate a dehumidifier, a humidifier, and can hold different settings for day and night. So what's the perfect environment? Well, that all depends on the stage of your plant's life. During the vegetative stage, the plant likes warm, humid environments. During the flowering stage, I run cooler temperatures and try to prevent humid conditions that may cause mold in the flowers. Alright, so let's say you have one plant in your grow room. You hung a nice light right above it and it's bright. The top of the plant is producing some beautiful flowers. But then you notice that the lower part of the plant is producing small, fluffy, light flowers. And they're not as frosty as your top flowers either. This shows you that light intensity really does matter. You see, even though the light's bright, it's not powerful enough to penetrate through that foliage. And those lower flowers aren't receiving enough light to grow to their full potential. You see, the inverse square law tells us that the brightest part is at the source. The further you get away from the source, the more the light covers, but the dimmer it becomes. This is the reason why most growers lollipop their plants. In this way, the plant's able to concentrate all its energy to those top flowers. Your overall quality improves. You see, the intensity of light affects everything from density, color, aroma, and trichome production. The flower on the left weighs 9 grams. The one on the right weighs 4 grams. Notice the color difference. By the way, these were grown using optimized conditions, so it's not such a good example. Flowers that don't receive enough light turn out horrible. Let's switch it up a little bit. Let's say you got that same light, but now you have 3 plants. You hung your plant dead center, and that middle plant is loving it. The other 2, not so much. You see, when the plants don't receive enough light in vegetative stage, they tend to stretch out and try to reach the light. They might even try to overgrow and kill that plant in the middle. You don't want your plant to stretch. They're hard to deal with, and worst of all, the branches could be weak. And you need strong branches to support the flowers in flowering stage. If we were to flower these plants, the plant in the middle would grow nice dense flowers, and the ones on either side would grow the weakest, shittiest, fluffiest herb you've ever seen. But what about the inverse square law, Callie? Can't I just move my light up and get better coverage? Sure. But remember, the further away the source, the dimmer the light becomes. And this might be even worse because all the plants will stretch and all the plants will create shitty flowers. The best solution would be multiple light sources. And something really special happens when you have more than one light. Cross-lighting. This can increase the overall intensity in that room. But there's a little bit more to this. You see, intensity is important, but so is the spectrum of light. Light is made up of a rainbow of colors. Some we can see, and others we can't. But plants don't care what we can see, because they don't have eyes. Instead, they have tiny organs called chlorophyll. These little cells are able to absorb different light color spectrums. Each one of them absorbs a specific color. And there's probably thousands of them on leaf. Now, these chlorophyll are only able to absorb light within a specific wavelength range, 400 to 700 nanometers. Everything else doesn't matter. This range is called the photosynthetically active radiation range, or PAR for short. Now, in order to test the intensity of that light, we have to test for PAR, because nothing else makes sense. The problem is that these PAR meters are kind of expensive. This Apogee quantum PAR meter cost me $300, and it's not even the best for LED lights. I always use a PAR meter when I set up a grow room. It not only shows me the light intensity at different heights, it also shows me parts of the room where the light doesn't cover, where it's lacking. And this, in the end, will help my plant reach its full potential. The seeds are really easy to germinate. I just need to provide water, warmth, and give them time. The seed will do the rest. They truly are amazing though. Inside the shell, you're going to find hormones and enzymes. It also has enough stored energy to power itself through the first few days of life. It uses this energy to push itself out of the soil to reach that sunlight. All we have to do to make this process happen is add water. I'm going to show you my 3 favorite ways to germinate a seed. Soil germination is one of the oldest and easiest ways to germinate your seed. I'm using Fox Farm Ocean Forest soil. It's important that the soil is evenly and completely saturated. I always plant the seed with the pointy side facing down. This is where the taproot's going to emerge. The only downside to this technique is that you don't know if you have duds until way later. The shot glass technique is also very easy, but it takes a few extra steps. All I have to do is drop the seed in the shot glass filled with filtered water. I'm using reverse osmosis water filtered by my high pure water system. The advantage to this technique is that you immediately know if you have duds. All I have to do now is place the shot glass in a warm, dark place and give it time. In the paper towel technique, I place the seed in the center of a damp paper towel. I then fold the paper towel and place it inside of a Ziploc bag. Just like the soil and the shot glass technique, the Ziploc bag goes into a warm, dark place. You can germinate more than 1 seed at a time with any one of these techniques. I'm going to do 5 of each, and we're going to test to see which technique is better. It's been 48 hours, and all the taproots have emerged from the seeds in the shot glass. I'm going to plant these in a cup filled with Fox Farm Ocean Forest soil. Only 3 of the seeds in the paper towel technique have germinated. I'm going to plant these 3 seeds and wait for the other 2 seeds to germinate before planting them too. It took 12 hours for the 2 seeds to show their taproots. I planted them as well. I can't tell what the heck's going on in the soil. We're just gonna have to wait on those. 12 hours later, all but 3 seeds have emerged from the soil. The 3 that haven't come up yet are on their way. They should be up in the next few hours. So all you need to germinate seeds is WWT, water, warmth, and time. I've been adding mycorrhiza to my seeds as they germinate for years, and I catch a lot of slack for this. So we're going to do a little experiment to see if it really is beneficial. Mycorrhiza is a type of fungus found in most soils across the world. This fungus attaches to your plant's roots and creates a mutually beneficial relationship. The mycorrhiza exchanges water and nutrients that it finds in the soil for the plant's sugars and carbohydrates. And this is not parasitic in any way because the plant has to be alive and healthy in order to produce those carbohydrates, and the mycorrhiza knows that. If the plant is big and healthy, it's going to produce a lot of carbs. But why does the plant want to partner up with mycorrhiza if it could pull its own water nutrients? Well, you see, mycorrhiza creates these web-like structures that kind of look like roots. The difference is that they grow a lot faster and cover a much wider surface area in a shorter period of time. Fungi also has a better ability to break down organic matter and convert it to plant-usable nutrients. Mycorrhiza also has the ability to transport these nutrients anywhere within its network. And that's major because plant roots can only absorb nutrients if they're in contact with them. But mycorrhiza does a lot of amazing things. It's actually able to interconnect plants and allow them to exchange nutrients. There's a fungi network in North America that covers over 2,000 acres, and it's been named the biggest living organism on Earth. Trippy, huh? Now there's two different types of mycorrhiza that I know of: endo and ecto. Endomycorrhiza attaches to the roots and penetrates its walls. Ectomycorrhiza just kind of sits on top. Mostly all mycorrhizal products you find on the market have a combination of both. Now the argument against using mycorrhiza on seeds is that mycorrhiza needs roots to attach to, and the seeds don't have roots. I've even heard people say that mycorrhiza doesn't survive past 12 hours once it's been wet. It generally takes 48 hours for seeds to germinate, and by then, the mycorrhiza will be dead, so they say. I believe that mycorrhiza is resilient, not as fragile as people think. So my idea is that the mycorrhiza is present when the taproot first emerges, inoculating that seedling from the start. I'm going to germinate 10 seeds in plain water. This is our control group. 10 more seeds in mycorrhiza, and I've also decided to do 10 seeds in seaweed extract. Seaweed grows underwater where there's really not much light. On top of that, the ocean is a rough place, and these plants take damage on a daily. But seaweed is able to overcome all of this and grow big and strong and repair itself really quickly. And this is primarily due to the abundance of hormones created by the plant. You see, all plants create hormones. Some of them are growth stimulants and other retardants. And some hormones create reactions with each other that affect the plant's growth or stages of life. Now, seaweed extract has over 70 trace minerals, but it doesn't matter too much because the seeds don't really need it. But the important part here is that these hormones are organic plant growth regulators. Now, I don't know if it's going to make a difference in these seeds because the seeds already have everything they need to grow contained within that shell, but it's worth a try, right? I mixed in 2 milliliters of seaweed extract into a quart of water. I poured a little bit of that water into the sandwich bag and let the napkin absorb it. The wet napkin is going to create a wet environment. The Ziploc bag sort of acts like a greenhouse and keeps the warmth inside and prevents the moisture from evaporating. All the seedling really needs to germinate is WWT: water, warmth, and time. It doesn't matter how you achieve this, as long as you have WWT, they will germinate. So let's get this show on the road. It's been 48 hours and most of the seeds should have germinated by now. 8 seeds have germinated in plain water. The taproots are poking out, and if I was planning on growing these out, I'd probably plant them today. You really don't need more taproot than this. 9 of the mycorrhiza seeds have germinated. Now, one of the seeds has a giant taproot, and this is impressive, but it doesn't really mean anything because it could just be genetics. And besides that freak, they all seem very similar to plain water. 7 seeds germinated in seaweed extract, but it doesn't look very impressive. Nothing special really. But this experiment is not about germinating the seeds because we know these seeds are going to germinate regardless. This test is about proving or disproving the benefits of these amendments. So now that the taproots are out, let's give them another 24 hours to see if the mycorrhiza actually attaches and the seaweed extract has any benefit. It's been a total of 72 hours, and the mycorrhiza has had plenty of time to attach. If it's not dead, like they say. The taproots in the mycorrhiza batch have grown extremely large, but on top of that, the taproots are covered with mycorrhizal hyphae. And this just proves that they were wrong. The taproot growth on the seaweed extract batch is even more impressive. They're humongous. They don't have the same kind of fuzzy hairs that the mycorrhizal batch does, but they're growing fast. The plain water batch hasn't really grown much, but it's doing okay. Well, does this prove that mycorrhiza and seaweed extract is beneficial to seeds? Well, maybe not the germinating process, but once that taproot emerges, it makes a huge difference. And I think my hunch was correct. Mycorrhiza is resilient. Look, man, I know this was just one experiment, and we probably need a lot more to come to a solid conclusion. But I'm just one dude, and I can't do it all by myself. And look, I'm not trying to convince you of anything, because like I always say,